Q, and that R there is Q. And we end up with, relying on, we'll put the burdens all on Justin.
And this is just accepted that 6.67 is times 10 to the negative 11th is the universal constant for gravity.
Yes.
For the 1.5 times 10 to the 11th, we just got that from, what does that number represent?
That's the orbital radius. That's how far it is from the center of the Earth to the center of the Sun.
Okay. And you wrote it as 1.5 to the 10th, or times 10 to the 8th, times 10 to the 3rd?
Yeah, because when Ibrahim looked it up, he gave it to me in kilometers.
Mm-hmm.
And so the kilo is 10 to the third.
Okay.
So I wanted to get in meters. That's why this is here.
And you just added the 8 and the 3 to the 11?
Yeah, when you're multiplying, if they have the same base, you would just add the exponents. Because really, if I have
It would just be like,
10 squared times 10 cubed, well, that's 10 times 10.
yeah.
That's 10 times 10 times 10. In other words, I got 5 of them. Do we have an answer?
How would you even go about plugging that in the calculator?
Depends on what calculator you're using. But 4 times pi squared. This, you would do 1.5. Is it the EE button or E?
I just literally typed in 1.5 times 10 to the 11th, pressed
Okay.
the enter button, and then cubed it after.
Okay, that's the other way. What you don't want to do is combine them, because I've seen the 1.5 times 10 and then hit the EE button 11, which adds an extra 10 in there. So what you get, Carolyn?
2.008 times 10 to the 30th.
Kilograms. This is mass.
Oh, what is it?
Yeah, M's used for too many things. M for mass, so it's kilograms. And I think the book's 1.99 times, let's see, Sun, 1.9891 times 10 to the 30th. So in order to do this, you just need to understand Newton's laws, assume a circular orbit, and be able to do precision experiments to get this value, which actually happened in the late 1700s. That's when they got the first shot at that.
How do you even go about finding that number?
In what I consider probably one of the 2 most tedious physics experiments of all time. One of the tedious experiments was done where they took gold foil and they shot alpha particles at it, which is basically helium nucleus with the electrons stripped off. And as the alpha particle hit the gold, if most of the time things would shoot out in the direction you were shooting, but occasionally that helium nucleus would bounce backwards. And so to test that, you basically had like a viewfinder, and you had it at this angle right here, and you counted the number of times that something would flash, and then you move it over here and count the number of times it flashed, and then you come over here and you basically go all the way around. One of the guys who did that experiment, that was the gold foil experiment, was Geiger. And so you can imagine his inspiration to come up with an easier way to count radiation. And in this one, you get a box so that breeze can't come into it. You dangle a mass on a very thin wire, perfectly balanced. You have another set of mass underneath it on a stand.
Is it touching it or no?
No, they're not touching. So you've got the ones dangling like this, and you got the other ones on a stand, and you put the ones in the stand in a particular place, and you see how this moves. Now to do that, you see how this wire, how much the wire twists. And as best as I can figure, the only way to do that is you have to have some sort of shiny thing on it, shine a candlelight on it, and see where the reflection moves. And if it's not airtight, let's say you're doing the middle of the experiment, somebody walks in, door opens, a little bit of a breeze, then you have to wait for it all to calm down again before you start again. There's a cruelty joke skit in there somewhere. That and the initial finding the radius of the Earth.
Wow.
All right. Questions on that before I adjust it slightly and head towards another potential cruelty joke skit?
Are we now going into chapter 6?
This is 6. You look disappointed.
No. So what concluded chapter 5 was the
I think centripetal motion is 6.
centripetal motions.
Yeah, but I'm not 100% sure on that. It all works together in my head.
So the omega, that stuff, that was chapter 5.
Well, we did the omega because we were dealing with circular stuff, so.
Right.
All right, I'm gonna take what we have down there in the corner. G mass of the sun over R equals four pi squared R squared over T squared. I'm gonna, because I know where I'm heading, I'm gonna take this R up there and bring the 4 pi squared down here. So I get G mass of the sun over 4 pi squared is equal to R cubed over T squared. So just a little bit of manipulation. Notice on the left-hand side, for anything orbiting the sun, this is the same number. That m sub s would be the mass of whatever the central body is. So this ratio of R cubed over T squared should be the same for every planet in the solar system. It'll be a different ratio for everything orbiting the Earth, but everything orbiting the Earth will have the same R cubed over T squared. This is one of Kepler's laws. So Kepler spent 40 years of his life coming up with the laws of planetary motion, with the stuff Newton has done. You could derive it in an afternoon. And I will say, have I done what Kepler read? No. Oh, that's okay. I say it's fortunate Kepler was dead by the time Newton came along, because I'm just picturing Kepler and Newton in a bar talking about what they were doing. Kepler says, yeah, I've spent the last 40 years of my life coming up with this laws of planetary motion. And Newton said, oh, how interesting. Every afternoon I can show you how to do it. However, on the other side of it, one of the reasons Newton's laws were accepted so quickly is the fact that you could derive Kepler's laws from it. And are we done? Have we done all the material now for the next test? Stuff to hand back. that. Did that. Uniform circular motion and gravitation, that's would be chapter 6. There's some more of Kepler stuff, but. eh. You know what? I think we should decide when we're doing quizzes, master sets. You know, neat junk like that. All right, so.
Is it next week fall break?
It is. So you don't want anything to do next week?
I would prefer not.
Just for you, Jack.
Thank you.
You have done master set for concept. You have not done application yet.
Not yet, that's due this Thursday.
Okay. Let's say master set 6 do the 19th. So master
Is that the Thursday after fall break?
Yes. Does that work for you?
And we said the test corrections were also due the 19th as well,
Yeah.
test corrections.
And test 1B. Say the 25th.
How many tests are there altogether?
Typically 4 test grades.
And
So
that's
it's-
the Wednesday after?
That's 2 Wednesdays after fall break. That's the Wednesday after the 19th.
Okay, yes.
Okay, so for the test B, we're gonna have centrifugal motion. We're gonna have, forces, facades,
Yes.
And,
Yeah. Yes.
Bethtones?
Pardon?
Like, we're gonna have forces, facades, and then some triple stuff.
Motion, which is still all part of the same thing.
and then this.
Which is still all part of the same thing.
Anything I'm missing?
Not in my head.
Okay.
All right, so we've done a quiz on 4, because I think those are in here, or I've handed them back already.
Should be.
Yeah, there's a quiz on 4. Quiz on 5. Well, we can do, what I'm thinking right now is we can do a quiz on chapter 5 or 6, and I don't care which one. Any preference?
Are we not gonna do a quiz on one or the other?
I don't think the timing's really gonna work out for us to do both of them. But we could do like 5 and 6 together, same day.
We can just do 5.
We can just do 5.
Just 5, okay. I'm thinking since the test is on the 25th,
The 24th.
I'm good with the 24th, obviously. They won't be graded before the test.
Right. The Tuesday, we come at, the Wednesday?
Lab day?
Do we have a lab that day?
Probably.
Probably.
We could do it the Thursday, then 19th, just when Master said.
So when master said 6 is due and about the time test corrections are due? I'm okay with that. I mean, test corrections, that's definitely a fuzzy due date. I just need to know when it's gonna be done if you're not ready by then,
Right.
if you're gonna do it. All right, quiz on chapter 5 on the 19th. The homework quiz on 5.
Do we have a pre-lab this week?
There is a pre-lab with that. I'm just gonna say, let's just skip the pre-lab this week. If you wanna do it, fine. If you don't wanna do it, fine. If you hand it in with work done on it, unless you say ignore, I will count it, and if you don't, I won't count it.
Can you do a thing where like it can only help your grade?
I think I will let you decide if it's going to help.
Okay, yeah.
So you said that chapter 5 quiz is October 19th, not this coming Thursday?
Correct.
Okay.
The master set application is due
Do this Thursday.
this Thursday.
Okay.
Other questions at the moment? All right.
If you could come and see this, I mean, this is just personal, I mean, it's related to the class, I can't find in the textbook where the homework questions are.
I have to go to the solutions, and then I just read the problem and then do it, and then just look at the solution. Because the number pages are different, I think.
Oh, are you on the online version or PDF?
PDF.
I think they're wrong.
They changed, did not.
I see.
So look at, so what Jack suggested, look at the
Okay.
solutions and the
Alright.
questions are written there.
Yeah.
And one of these years I'll update that.
It's not-
How dare they update the textbook?
Without checking with you.
I know. Really, seriously.